doing one equations. So just let's take some notes real quick. When we solve equations, we are trying to find the value that makes the statement true. Okay, so when we solve equations, we are trying to find the value that makes the statement true, right? I think you guys know this instinctively, but we're just like putting words to what we do in math. So if I have, right, like question mark plus 3 equals 8, we're just trying to figure out what makes this true. What is that question mark, right? Usually it's a variable. Usually we see it with an x. And we know that, right, x equals 5. 5 plus 3 equals 8. So a lot of you know that instinctively, but this is actually like solving equations, right? All right, so we have a verbal form and then the opposite or inverse and then the solution. So let's start with the first problem. We have question mark plus 5 equals 12. And I know a lot of you can probably just do this in your head, but again, we want to take notes. So the verbal form, right? An unknown value plus 5 equals 12. Right? You want to be able to write that in words, right? An unknown value plus 5 equals 12. So the opposite of that, because we're adding 5, is we are subtracting 5. And I think you guys know that the answer is 7, right? 7 plus 5 equals 12. But to get that, we do 12 minus 5. All right. Second example, 3 times a number equals 12. So the verbal form is 3 times an unknown equals 12. Right? Again, we've seen this before. We know how to do it, but now we're putting words to it. We're being very specific with our vocabulary. So the opposite of multiplying is dividing. So dividing by 3. Because before we were timesing by 3. And so our solution is, right, 3 times what equals 12? 3 times 4 equals 12. Okay. Hopefully not so bad. We only have a few more examples. Let's look at number 3. Number 3 is going to be x over 2 equals negative 5. So another way to think about it is like what is bothering the variable? Like what is in the way of the variable? So right now we have division is by our x. And so the inverse of that is going to be multiplication. Right? So if we do x over 2 equals negative 5, we want to do the opposite. So we want to multiply both sides by 2. This cancels out. The 2 on the top and the 2 on the bottom cancel out. And then we have x equals negative 10. So even though you probably do this instinctively, right, you're doing the inverse operation. You're doing the opposite operation. So we always want to check, right? So if I have negative 10, if I'm in a test situation, like you can know if you get it right or wrong. You don't just have to guess and give it to the teacher to grade. If I think x is negative 10, I'm going to plug it in to my original equation. So I have negative 10 over 2, that equals negative 5. So I know that I got it right. So you can know if you get it right before you even turn it in by just checking what you get and plugging it back into the original problem.
Don't forget to check.
Yeah, you have to put a check.
Where did you get that 2 from?
Which 2?
The 2.
Because I multiply both sides by 2.
So it already came with the 2 or what?
It's because x here was divided by 2. So I wanted to do the opposite, the inverse. So instead of dividing by 2 like originally, I multiply by 2 on both sides. Yeah? Good question. Okay, so for this one, we have a negative 5x equals 30. Bless you. So what I like to do is I like to draw this line on the equal sign because the equal sign is like never going to move. And so you always want to move stuff around so that x is by itself. X is like a loner. Like, Doesn't like anyone. Antisocial. So right here, we were timesing by -5, so we're going to do the opposite. We're going to divide by -5 on both sides, right? So we're left with just x. The equal sign is still in that middle, and then 30 divided by -5 is -6. And then we have to check it, because I said so. So -5 times -6 is positive 30, right? Two negatives equal positive. So we can put our beautiful check mark. And we know that we got it right, because we're so smart. All right, for number 5, 6.25 plus k equals 2.75. So this one, you could probably use a calculator. I would let you use a calculator. So we have our equal sign with our line down the middle. We minus 6.25 from both sides, because we're doing the opposite, right? Before it was a positive 6.25 plus k. K is being antisocial. It's getting the 6.25 to go away. So we're subtracting it. So we're left with k equals negative 3.5. And again, I'd probably let you use a calculator for that. And we can always check it. 6.25 minus 3.5. We could do this without a calculator. We get 2.75. So we did that one right. Okay, so the next two problems I want you to try on your own, and then we will see if we get them right. Okay, so this one is n over 7 equals -3, and number 7 is h minus 1.4 equals negative 3.5. All right, so try to solve those on your own, and I will come check and see. Okay, so saw a lot of good math. Draw our line in the middle. It's n divided by 7. The opposite of dividing by 7 is what, Michael? What's the opposite? Opposite of dividing by 7. Yes, times 7. So this cancels out. We're left with just n, negative 21. And we can check it. Negative 21 divided by 7 is negative 3. Amazing. All right, we have our line. It's h minus 1.4, so we're going to do the opposite. Plus 1.4 plus 1.4. We get h equals minus 2.1. Right, because it's a really negative number. We're making it a little less negative. And then we're going to check it. Negative 2.1 minus 1.4 is negative 3.5. All right, so this is one-step equations. The reason why it's called one-step equations is because you can do one step to solve it. All right, so the one step here was dividing by -5. The one step here was minusing 6.25. The one step here was timesing by 7. Right, there's only one step. So if you're trying to do all this complicated stuff, you're doing 5.1 wrong. So good luck on your one-step equations.
Thank you.